Hi everyone. It's my pleasure to report at ICPC 2025. I want to talk about a tough problem: finding logic bugs in database management systems. DBMS like MySQL and SQLite are used every day. They store and manage data for almost everything. Banking, online shopping, they're used everywhere. Because they're so important, bugs in these systems can cause big problems. Some bugs crash the system, which are easy to spot. However, logic bugs are tricky because they don't crash the database. Instead, the database just gives back the wrong answer without any warning. This makes them really hard to find. Here's a quick example. This query should give back infinity. But because of a logic bug, SQLite gives back null instead. It looks like it worked, but the result is wrong. And if you don't know the right answer should be infinity, how do you even know there's a bug? That leads to the main challenge. How can we automatically check if a database result is correct if we don't know the right answer beforehand? This is called the test oracle problem. One clever way people have tackled this is using metamorphic testing. The basic idea is you take a starting query, a seed query, and change it in a logical way to make a new query. The results of seed query and the new one should align the logical relationship. For example, rewrite it to be equivalent. Their results must match. If they don't match, you found a bug. So the challenge becomes, how do we design the metamorphic relationship? When we looked at the kinds of logic bugs found before, we noticed something important. Most of them come from the query optimizer. That's the part of the database that tries to make queries run faster. When the optimizer makes a mistake, we get these optimization bugs. So, a good bug finding method should really focus on this optimizer. But when we look at older bug finding methods, they have some problems, especially with these optimization bugs. Take this example. The first type of method only looks for differences in the number of rows returned. But here, the right answer and the wrong answer both have 2 rows. So, these tools would miss this bug completely. Other methods can check the actual content of the results, not just the row count, but they often aren't very good at specifically finding bugs caused by the optimization process itself. They might find some bugs, but they aren't always targeted at the main source. To solve these problems, we came up with a new method we call SAMBUG. It stands for Semantic-aware non-optimizing query generation. SAMBUG is based on metamorphic testing. It can not only specifically find those tricky optimization bugs, but also handle semantic information. So how does it work? It happens in 2 main stages. Stage 1. Transform the query. We generate a query that the database will try to optimize heavily. Then, we change it into a new query. That means the same thing, but it's much harder for the database to optimize. The idea is that the complex code used for optimization is more likely to have mistakes than the simpler code used for non-optimized queries. Stage 2. Check the results. We ran both the original query and our changed non-optimized query. Then, we compare their final results. Let's look at the details. First, we create random tables and queries, making sure the queries have where clauses. Where clauses are very common, and databases work hard to optimize them, for example, by using indexes. Next, the key change. To force the database not to optimize so much, we take the condition from the where clause and move it into the select part. And the new column, let's call it flag, that checks if the original where condition is true for each row. The important part is that this changed query usually doesn't have a main where clause anymore. This often forces the database to scan the whole table instead of using faster optimization tricks. After changing the query, we run them and compare. Look at this diagram. If only row v1 should pass the where condition, the original query might use an index and just return v1. Our changed query scans everything. and creates the flag column. It will be true for v1 and false for v2 here. Now, the changed queries result includes rows that should have been filtered out. To compare fairly, we run a simple filter on this result. We select only the rows where flag is true. This gets us back to the original meaning of the query. Finally, we compare the result from the original query to this filtered result from the changed query. If they aren't identical, we found a logic bug, likely caused by a faulty optimization. Does it actually work on real databases? We asked some questions to check. First question, can Sandbug find semantic logic bugs in the real world? Yes. Here's a bug we found in TiDB version 7.5.0. The original query and our Sandbug query returned the same number of rows, but the actual data was different. This was caused by the optimizer choosing the wrong index. One of the TiDB developers even said about the bug, "The behavior is a bit tricky. This shows Sandbug can catch subtle problems." The second question is, how well does Sandbug do compared to other bug finding techniques? This table shows the results. We ran Sandbug and other top tools for 24 hours on different databases and counted the unique bugs each tool found. As you can see, Sandbug performed the best. It found the most unique bugs on every database we tested, and found significantly more bugs overall than the older methods. So Sandbug finds more bugs, but can it handle complex SQL features? We checked which features different tools support. This table shows Sandbug supports many advanced features, like aggregate functions, sum, AVG, and window functions. Can Sandbug find bugs in complex features? Yes. Here are a couple of examples we found. First, a bug in SQLite where the sum function gave the wrong answer because of a number overflow that happened during optimization. Second, a wrong result caused by a bug in a window function. Sandbug found this bug, but another tool missed it. This shows our method is good at checking the meaning, even in complex situations. So, to sum up, we developed Sandbug, a new way to find logic bugs, especially for optimization bugs. It works by comparing a normal query with a less optimized version while carefully checking the result's meaning. Our evaluation shows that Sandbug finds important, real-world bugs, works better than previous tools, and can even find bugs in advanced SQL features. That's all. Thanks for listening.